Hello everyone. In this video, we will be familiarizing ourselves with factoring and the different methods we have available to factor polynomials. First off, let's remind ourselves of some terminology. For this topic, we will be focusing on polynomials. By polynomial, we are referring to some expression involving variables being added, subtracted, or multiplied where all the variables are raised to non-negative integer exponents. So just for an example, 8x cubed plus 8x squared y plus 2xy squared would be a polynomial. In most cases, we will be interested in factoring polynomials with only one variable, but in general, they can have any number of variables. Our methods of factoring will often apply to only certain kinds of polynomials. Ones we will be talking about the most include trinomials. These are polynomials with 3 terms in them. Quadratics, which only have one variable and the highest power is squared, as well as cubics, which also only have one variable with their highest power being 3. Next up, let's make sure we understand what we mean by factoring. Going back to just simple numbers, factors of a number are whole numbers that can multiply together to give the original number. Taking 30, for example, we can factor that or split it up into two numbers that multiply to give 30. Here we could go with 3 times 10. Both 3 and 10 are factors of 30 because they multiplied together to give 30. To completely factor this number, however, we don't want to stop there. We want to factor as far as possible. This includes trying to factor the numbers we just factored 30 into. Well, 3 can't be split up any further, so let's leave that as just 3. But 10 we could split up into 2 times 5. Now 2 and 5 can't be factored any further, so the complete factorization of 30 is just these factors, 2, 3, and 5. We will be applying this same idea to factoring polynomials. We want to split up the original polynomial into factors that multiply each other to give back the original expression. And we want to factor it such that these pieces that multiply together cannot be split up any further. The first method of factoring we will discuss is the greatest common factor, or GCF. This process involves factoring out something that every term in the expression has in common. You can think of this as the opposite of distribution. To get a better understanding of this, consider factoring this expression, 3x cubed plus 12x squared. The process is actually fairly similar to simplifying fractions, where we are looking for what could fit into both of these terms along with what variables they have in common. If we start by focusing on the coefficients, the 3 and the 12, we notice they are both divisible by 3. 3 can fit into both of them. So we can factor or pull out that 3. And that is going to be multiplying whatever is left when we factor that out. Well, what would be left is just the same thing, now divided by the 3 we have pulled out. So in the set of parentheses, the terms we had before are now being divided by whatever we factored out. If we do the division, we will just get x cubed plus 4x squared. There's nothing else we can do with the coefficients, so let's move on to the variables. We want to think about the variables that each term has in common. And we see that each has at least one power of x. So let's pull a power of x out. When we divide out that power of x, here's what we're left with. Simplifying that, we'll get x squared plus 4x. We see there's still a power of x in common, so let's factor that out as well. At this point, we'll go ahead and just do the division. Factoring out the power of x, we'll just leave x plus 4. At this point, I'll go ahead and combine all the factors out front, leaving us with this. We now have 3x squared times x plus 4. And there's nothing else we can pull out, so there is no more common factors. If this step-by-step process is easier for you to think about, then there is nothing wrong with taking these small common factors out one by one. However, we could have also noted that this 3x squared we ended up factoring out was actually the greatest common factor of our expression. And we could have pulled that out in one step. It's worth noting that the nice thing about factoring is that it always has a way we can check ourselves. If we were to redistribute this multiplication, we can make sure that what we get back is what we started with. If you find that you get something different than the original expression, then you might have made a mistake somewhere. Now that we've discussed common factors, let's talk about factoring by grouping. We use grouping when there are no common factors between every term, but there are some common factors if we group up the terms. This process mainly applies to polynomials that have 4 or more terms. Cubics are a common polynomial for grouping. Let's look at this example. There are no common numbers or variables that all of these terms share, so we can't pull out a common factor from the whole polynomial. However, let's try grouping these first two terms together and these second two terms together. Grouping them up like this, we can see that the first two terms have a factor of x in common. So if we go ahead and pull that out, we will be left with 2z plus 1. For the second two terms, we see they have a y in common. So pulling that out, we'll be left with minus 2z minus 1. At this point, note we almost have a common expression here and here. They only differ by a sign. If you ever see this happen, we can factor out a minus 1 to change the signs in this expression to match the other. And this is the real goal of grouping. To group things up such that when you factor out from each group, you're left with matching expressions in the parentheses. Once you get to that point, the expression in the parentheses becomes a common factor itself. And just like before, we will pull out that common factor. If we pull out this factor, what will be left to multiply it will just be whatever terms the factors were multiplying beforehand. So that was x and a minus y. So going through this process, we have rewritten our polynomial as two factors multiplying together. Again, we could check our answer here, multiplying back out to make sure we get the same expression we started with. But to accurately do this multiplication, we will want to make use of the FOIL method. If you want a refresher on the FOIL method, be sure to check out the Math 171 video we have available on our channel. Next, we will mention one of the key methods of factoring polynomials, the AC method. This method is mainly for trinomials, such as quadratics, and the A and C refers to how we tend to write the coefficients of quadratics, the A being in front of the x squared term, a b in front of the x term, and the c is the constant. The steps of the method are as follows. First, multiply the a and c together. Second, factor that number into two numbers. We'll call them b1 and b2. So b1 and b2 will add together to give the b in your quadratic. Third, split the b in your quadratic into b1 plus b2. And the reason you do that is so you can do the next step, which is just factor by grouping. For an in-depth look at this method, check out our Math 171 factoring by grouping video we have on our channel. And with that, we've gone over the general methods for factoring polynomials. We will continue this topic in our next video, focusing more on some special cases. Be sure to check it out.